Having understood Fischer's projection formula, let's get into Haworth's formula. Alright, now in case of Haworth's formula, what basically happens is this cyclization. Now we have got OH over here. Now we know that this O, all the O's which are there, they have two lone pair of electrons. Alright, so this lone pair of electron is going to play some magic now. Alright, now let's understand what magic it does. Now check out over here. Now this is how I have represented over here. Now this is H, this is O. Now this lone pair of electron does a nucleophilic attack on this carbonyl of aldehyde. Alright, now why does it do nucleophilic attack over here? It does nucleophilic attack over here because carbon has delta positive charge. Because C double bond O, sigma bond, pi bond, and oxygen electron withdrawing group. So it pulls the pi bond towards itself, getting delta negative and generating delta positive over here. And this is a nucleophile, so it just goes and attacks to the delta positive carbon of carbonyl. Alright, so that is how it does. And as it does so, the pi bond climbs on oxygen and becomes O negative over here. Alright, O negative over here. Alright, so the same thing happens here also. In case of fructose also we see the same thing. Now here again carbonyl, the same story, delta positive, delta negative, nucleophile attacking over here. Alright, attacking over here, and this pi climbing on oxygen, rendering it O negative. Alright, then let's understand what happens further. Oxygen 3 bonds, so oxygen is positive. So what it does is, so H is still attached there and there's a bond between O and H, but O is positive. Why? Because O has got 3 bonds there. So what it does is it withdraws that bond to get satisfied, and this becomes now proton, H plus. O minus over here does the nucleophilic attack on that H and takes away that H over here. Similarly here also OH bond is there. O withdraws the bond, gets satisfied, and this does a nucleophilic attack on this proton. Alright, and as a result of that, the structure that we end up with is, now we need to understand what all differences has occurred while cyclization. Now if we check out over here, this was an aldehyde group, whereas this carbon 1 was aldehyde, whereas here it had formed all. So from al, it has formed all. Apart from that, this is a prochiral carbon. Prochiral carbon means that if you do something to it, it would form a chiral molecule. So let's check out over here. Now we know when we say chiral carbon, it should have 4 different groups attached. So when we check out this carbon, we would find we have got OH over here, we have got H over here, we have got this group attached over here. So 4 groups attached are different. So this was prochiral, this was non-chiral, prochiral, but this became chiral. Alright, so we added one more chiral center to the molecule. Same thing if we check out over here, the same story over here. This was ketone, a carbonyl, again a prochiral. So when this attached over here, what happened is it became a chiral carbon. Carbon to which is attached this group, this group, this group, and this group. 4 different groups attached to carbon. So this also becomes chiral. So this was prochiral, non-chiral carbon, which got again converted to chiral compound. Alright, and obviously the 5th carbon had this H, which got migrated over here. Similarly over here, 5th carbon which had this H of OH got migrated over here, migrated over here. So this got migrated over here, and so we got this anomeric carbon, we got this anomeric carbon, which was carbonyl earlier. When we observe this carbon and this carbon, it's sp2 hybridization over here. sp2 means 3 groups attached to this carbon, 1, 2, 3 groups attached. So it is sp2 hybridized planar structure, whereas here it is sp3 hybridization. sp3 means 1 of s and 3 of p, so 4 groups attached, 1, 2, 3 and 4. So here it was sp2 and here it is sp3 hybridization. The same story goes here also. Here in this case this was sp2 hybridization, 1, 2 and 3 groups attached, so it was sp2 hybridization, whereas here it was sp3 hybridization. One carbon to the carbon, central carbon, were attached 4 groups, 1, 2, 3 and 4. So that's yet another difference. And if we study cyclized structure of fructose and glucose, we already saw this is a 6-membered ring and this is a 5-membered ring. Now why 6-membered ring and why 5-membered ring? Why not smaller rings? Why not this OH coming and attaching over here, getting cyclized? Or why not this OH coming and cyclizing? Same thing over here. Why not second, third carbon doing the cyclization? It's all based on thermodynamics. In thermodynamics, it's told that cyclic structure with 5 to 6 to 7-membered ring are most stable. Above or below are less stabler. Alright, so owing to which we see here 6-membered ring and here we see 5-membered ring. Okay, let's proceed ahead now. Haworth formula. So these are the Haworth formula. Now we would study this in detail in incoming video.